So, Mesolithic 1 period Scandinavian fisherwoman in Norway, Hum1. I share 0.94% of my DNA and I'm apparently genetically closer to this sample than 23.4% of other genome link users. Hum1 is a sample from a 35 to 40-year-old woman of the Mesolithic Scandinavian hunter-gatherer population whose remains were excavated in southwestern Norway on the island of Hummervikholmen in the Søgne archipelago. Her skeleton remains are dated to be from 9,452 to 9,275 years old. DNA was extracted from her left second maxillary incisor tooth. Her mitochondrial DNA haplogroup is U5A1. Only her cranium was found, as the last ice age ended at approximately 23,000 years ago. New habitable places appeared in Scandinavia, first for plants and animals, then for the human colonization that started around 11,700 years ago. It's believed that the Scandinavian peninsula was colonized from two directions: from the south by western hunter-gatherers who came from Western and Central Europe, and from the northeast by the eastern hunter-gatherers who came from East and Northeastern Europe. The admixture of the two groups created the Mesolithic Scandinavian hunter-gatherer population. The most likely migration route on the eastern hunter-gatherer is via the North Atlantic coast of Norway. They had a more advanced stone tool technology named the pressure blade technique. Consequently, the resultant Scandinavian hunter-gatherers in the south show more similarity to the western hunter-gatherers, while in the north and east of the peninsula they have a more eastern hunter-gatherer component. Mesolithic populations living near the coast, such as the group to which the Hum1 woman belonged, had a maritime diet. There is evidence that the fisher hunter-gatherer population in southern Scandinavia already practiced fish fermentation and had established fisheries. Stable carbon and nitrogen isotope analysis of material from the Hum1 woman indicated that she had a diet rich in seafood and sea mammals. It's hypothesized that the cold environment and high elevation required special adaptations. The TMEM131 gene is associated with physical performance, endothelial function, and heart dimensions. There is one specific haplotype on this gene, composed of around 10 SNPs, that was frequent in the Scandinavian hunter-gatherers and today have the highest frequency in Northern Europeans, especially Finnish people. The SLC24A5 and A2 genes affect skin pigmentation, while the OCA2 and the HERC2 genes determine eye colour. The gene variants predisposing to light skin and blue eye colour were common among the Scandinavian hunter-gatherers, and even more common than among the eastern hunter-gatherers, indicating that they became positive selection factors in Scandinavia and became fixed in today's northern European population. The modern Scandinavian population still retains partial genetic continuity from the Scandinavian hunter-gatherers. The mitochondrial haplogroup U5 appeared in Europe and it diverged into U5A and U5B. It was as frequent as 65% among the Mesolithic Europeans. Today it's present in approximately 7% of modern Europeans. The U5A1 mitochondrial haplogroup of Hum1 probably originated in Eastern Europe and today has its highest frequency in Eastern and Central Europe. To figure out exactly how these women survived, scientists performed stable isotope analysis on the bone collagen of the Hummervikholmen skeletons. The trophic level isotopic testing reveals extremely high values for carbon and nitrogen. In forensic archaeology, high nitrogen signatures place an individual at the very top of their local marine food chain. Their diet was almost exclusively marine-based, Rather than hunting deer or foraging land plants, these women relied heavily on seals, small whales, deep water fish like cod, and coastal shellfish. Childhood versus adulthood, layered testing on their teeth, which record early life, compared to their dense bones, which record the last decade of life, shows a consistent, lifelong signature. They were dedicated, generational maritime specialists from birth to death. Bringing Sol to life, the facial reconstruction. Oh, I'm going to try and get a photograph of that. In exhibits at the Historical Museum in Oslo, the face of the primary Hummervikholmen woman, nicknamed Sol, in brackets the sun, was meticulously brought to life. Because her skull was broken into fragments on the seabed, scientists first performed a high-resolution CT scan of her bone pieces. A digital model was generated at University College London to virtually assemble her skull shapes with perfect structural accuracy. Using the forensic method, tissue depth markers were attached to a 3D printed replica of his skull. Sculptors laid clay to mimic the facial muscles of a woman of her age group. They used advanced genetic mapping, specifically utilized the genotype probabilities of the male individuals Hum1 and Neo17 buried with her to predict physical traits. The data indicated that Sol and her community most likely possessed a unique combination of dark hair, mixed brown or blue eyes, and a skin tone ranging from intermediate to light. This distinctive appearance was highly common among early Mesolithic Scandinavians, dispelling the old myths that ancient Europeans all possessed uniform fair features. So how do they, because they're connected, how does their mtDNA connect with my mtDNA? So the mitochondrial haplogroups U, the lineage of the woman of Søgne, and J1C3, which is mine, are related in two major ways. Deep evolutionary through a shared prehistoric maternal ancestor, and historically through the collision of two completely different cultures in ancient Europe. The deep genetic connection, the root ancestry. Both haplogroups are branches of the same massive maternal family tree. If you trace U and J1C3 far enough back in time, they meet at an ancestral clan mother. The shared ancestor, macro haplogroup R. Roughly 55,000 to 60,000 years ago, a woman belonging to the haplogroup R lived in Southwest Asia. Every person carrying a U or J lineage today is her direct maternal descendant. The split, haplogroup U branched off almost immediately around 50,000 years ago. Her descendants migrated into Ice Age Europe and became the dominant lineage of early hunter-gatherers. Macro haplogroup JT branched off separately, eventually giving birth to haplogroup J about 45,000 years ago in the Near East. Further mutations over thousands of years down the J line created the specific subbranch J1C3 around 7,000 years ago. The relationship between U and J1C3 is the defining genetic story of Europe's transition from the Stone Age to the Farming Age. Haplogroup U, the indigenous foragers like Sol, the individuals who carried U lineages, were native to Europe. For thousands of years they tracked game, crafted stone tools and adapted to maritime life. Haplogroup J1C3, the incoming farmers, this lineage developed among the earliest agricultural communities in Anatolia, modern-day Turkey, and the Near East. As the Neolithic Revolution took hold, these farmers migrated northward across Europe, bringing wheat, livestock and pottery with them. The turnover. Academic studies on Scandinavia's phylogeographic history show that as the agriculturists advanced, the diverse native haplogroup U lineages were gradually replaced or absorbed by the incoming farmer, associated with lineages prominently including haplogroup J. Today, if you carry J1C3, it means your direct maternal lineage traces back to those trailblazing Near Eastern farmers who expanded into Western and Northern Europe during the Stone Age. If you carry U, like Sol's U4 branch, your direct maternal line belongs to the original deep-rooted hunter-gatherers of the European continent. Next in this era is the black-haired hunter-gatherer in Britain, England. This is a cheddar man.